Hoi hoi, Mr. Nickerson here, and today we're going to talk about 7.3, which is solving systems of equations by elimination using addition. If you can pull out your notes that you received in class, and we'll get started. You can solve a linear system by adding the equations to eliminate one variable. There's a couple steps to this, and first you need to identify what variable you're eliminating before you even get to step one. What you need to have is that you need to have an a or b value, or the numbers in front of the x's or in front of the y's, such that it's the opposite numbers of each other. Reviewing what opposite numbers are is that opposite numbers are the same number but the opposite sign. So for example 1, 3x and negative 3x are opposite numbers. Since we have that, we're ready to go into elimination. We're using addition each time. Some videos online, other teachers will show you by subtraction, but I think the safest bet is to use elimination. You set up your addition bar here, put a big plus sign outside. And now we're doing step one. We're eliminating one variable by adding. You add vertically. 3x plus negative 3x, that eliminates. 4y plus 5y, 9y. 8 plus 10, 18. Now, we solve for that variable. Well, basic right here. 5 by 9. Y is going to be 2. Once we have y equals 2, we substitute that value into the original equations to solve for the other variable. Doesn't matter that you plug it into both, you just need to plug it into one to solve, but you're going to plug in twice when you check. I'm just going to erase that dashed line. I can choose either one. I'm going to choose the first one. So 3x plus 4 times 2 equals 8. 3x plus 8 equals 8. Minus 8. 3x equals 0. So x equals 0. And now, finally, just like we did yesterday, and the same for solving by graphing and substitution, we're going to check. Check it in both originals. So 3. So 0 plus 8, that does equal 8. And then check in your second. You got to make sure you check them both. Zero plus 10. Sure enough. Alright, let's take a look at example 2. For example 2, we first want to analyze and say which variable has the opposite numbers in front. Well, x has got 4 and negative 2. Y has got negative 3 and 3. Well, we want the opposite. It's got to be the same number but opposite sign. So we know where this time we're eliminating our y. We start off same way. Put our addition sign, our bar underneath, and we're going to add vertically. 4x plus negative 2x, 2x. The y is eliminating. And 5 plus negative 7, negative 2. Divide. And x equals negative 1. Once we have that answer, we substitute that value into one of the original equations, and we solve for the other variable. Well, either one's fine. I'm going to touch this up a little bit here, make it easier to see. And we'll choose the top one right here. We'll go 4 times negative 1 minus 3y equals 5. Negative 4 minus 3y equals 5. Add the 4 over. We'll move it up here for you, folks. 5 by negative 3. And y equals negative 3. Once we have that answer, we need to check it in both equations make sure that checks out. So we'll do the check right here for me. So we got 4 times -1 times -3 equals 5. Well, -4 plus 9 equals 5. Would you look at that? That checks. Now let's see if we've got the full check here. -2 times -1, +2, minus 9 equals -7. Sure enough, they both check out in our answer, -1, -3. All right, let's take a look at example 3. Okay, for example 3, we start the problem obviously the same way. We look for which variable we're going to eliminate first. What variable has the opposite numbers in front? Well, 5 and 7, those aren't even the same number. And then we got +6 and +6. So right now, we don't have the opposite numbers in front. But we see here that we have a +6 and a +6. We want one of those to be positive, one of them to be negative, so we can do elimination. So we have to apply one skill. And that skill is going to be multiplying one of those equations. Doesn't matter which one, but we need to get one of them positive, one of them negative. And there's a thing we can do to any equation to keep it balanced is, whatever you do to one side of the equation, if you do it to the other, it remains balanced. It remains the same equation when you solve it out. What we want to do is multiply one side and then the other side by -1. When you do that, what happens is, well, let's rewrite it. -1 times 5x makes it -5x. -1 times 6y is -6y. And -1 times 4 is -4. I can rewrite my other equation below it. And now, this problem is no different than the problems did on the first page. Write our big plus sign. Put the bar underneath. These are eliminated. 2x, 4, divide by 2. So we get x is 2. Write that there. Plug it into one of the equations. When you want to plug it in, always plug it to one of the originals. So I'm going to plug right here. 7x plus 6y. So 7 times 2 plus 6y equals 8. 14 plus 6y equals 8. 6y equals -6. And then divide and get -1. And then from there, you'll check it on your own. Check here. 5 times 2 plus 6 times -1 equals 4. 10 minus 6. Would you look at that? Does check. Check the second equation. 7 times 2 plus 6 times -1 equals 8. 14 minus 6. Would you look at that? They both check out, and our final answer works out. Alright, let's take a look at example 4 here. First off, fractions. Not everybody's favorite thing in the world, but still solve these problems the exact same way. We already have the opposite numbers in the -2/3 y and +2/3 y, so we can add and get 3/4 x equals 3, multiply by our reciprocal, and then get x equals 4. Once we get x equals 4, I went up to the top right and then found y, got -9, as you can see the work there on the board, and then from there we check 4, -9, and sure enough, would you look at that, it checks out. Alright, take a look at example 5. You're saying to yourself, Hold the phone. We've got A's and B's. What in the world is going on? No need to fear. Elimination is here. When you have an A and a B, or if you have a C and a D, or you have an X and a Y, you treat them the same way. Whichever letter appears first in the alphabet, this time which would be A, would be your X. Whichever letter appears second would be your B, which is Y. Okay? So, treat this problem the exact same way as you solved the previous examples. When you write your ordered pair, your A value goes first, your B value goes second. Alright, so we start off example 5 by needing to make one of the variables have the opposite numbers. We see the positive and positive 2b in both equations, so I'm going to make one negative, and as you can see I multiplied the top equation by negative 1. Once having that, I rewrote my equations, and then I performed my addition. 4a equals 16, you get a equals 4. Once you have that coordinate, I went down to below where I wrote my ordered pair, found out b, found it out was negative 7. Got my answer, checked them both out, they both work. Would you look at that? Alright, if we want to go over the final example, example 6, we first need to start off by getting the opposite numbers on one of the variables. Well, I took the y's, they had the same number coefficient, negative 3 in front, and made one of them positive by multiplying the top equation by negative 1. I rewrote those equations, I added, I got negative 7x equals 21, and then, as you can see, x equals negative 3. Plugged that into one of my equations, was able to get y equals negative 5. Did my check work at the end. They both check out. Would you look at that? And that concludes today for solving systems by elimination. Hasta la vista.